Alright, graphs of rational functions, 2.5a. A rational function is anything with a fraction. It has a top and a bottom. It's defined as a quotient of two polynomial functions. And then it gives you some definitions for vertical asymptote, horizontal asymptote, and slant asymptote. And this is what you really need to know. To find the x-intercepts, they always come from the top. We're going to set the top equal to 0. The vertical asymptotes are going to come from the bottom, so set the bottom equal to 0 and solve it. The horizontal asymptotes, you have 3 rules. If the degree of the bottom is bigger than the top, then it's automatically 0. If the top and bottom are the same, it's the coefficients. If the top is bigger than the bottom, there's a slant. There's no horizontal. No horizontal. The whole is where something cancels, and to find the slant asymptote, you divide bottom into top. And let's just do some here. I'm going to go through and find one thing at a time. First thing it asks me for is the x-intercepts. To find the x-intercept, you set the top equal to 0. So if I set the top equal to 0, I'm going to get 0. Again, 2x equals 0, I'm going to get 0. X equals 0, I'm going to get 0, and 0. If it had been something else up there, I would have solved it. But then I'm going to go ahead and I'm going to find the horizontal. The horizontal, there's rules. Rule number 1, if the bottom is bigger than the top, then it's automatically 0. Rule number 2, if the bottom and the top are equal, then it's y equals the coefficients. And rule number 3, if the bottom is smaller than the top, then there's none. Okay, what do I mean by that? I mean the exponents, the degree. Right here, 1 equals 1, so they're the same, so it's the coefficients. So it's this right here. So it's just y equals 1. This one, the exponents are the same, so it's the coefficients, so it's y equals 2/3. This one, a 2 is bigger than a 1, so the bottom is bigger. If the bottom is bigger, then it's y equals 0. The bottom is bigger than the top, y equals 0. The vertical, you set the bottom equal to 0. So if I set x plus 2 equal to 0, I get x equals -2. That's my vertical. 3x minus 1, add 1, divide by 3. 3x equals 1. Wait, x equals 1/3. This one, I would add 4 to both sides. X squared equals 4. X equals plus or minus 2. And this one, I get an I, so it has none. Now the domain is everything. It's always all real numbers except for, and what is domain? Domain's x or y? Well, domain is x, so it's all real numbers except for my vertical asymptote. All real numbers except for my vertical asymptote. All real numbers except for my vertical asymptote. And this one's all real numbers except none, so it's just all real numbers. My range goes with my y, so these two always go together. These two always go together. So it's all real numbers except for 1, all real numbers except for 2/3, all real numbers except for 0, and all real numbers except for 0. Okay, now we're going to find the slant. The slant occurs when the degree of the top is bigger than the degree of the bottom. Well, 2 is bigger than 1, so what you do is you divide top into bottom using long division to find the slant. And we've already done this, so what do you got to multiply by x to give you x squared? Well, x times x is x squared minus, gone, bring down my -2x. What do you multiply by x to give you -2x? -2. -2 times x is -2x. Bring down your plus 1. Wait, that's 0x plus 1. So my remainder is 1. Instead of saying plus 1 over x, for our slant asymptote, we throw the remainder away. So I don't care what it is. My slant asymptote is y equals x minus 2. Same thing here. Oops, what am I missing? What am I missing? I got to put a 0x squared in. And, alright, what do you have to multiply by 2 to give you 3? You can't have decimals. They're okay. 1.5. 1.5 times 2 is 3. Gone. 0x squared, so plus 0. And anything beyond, there's nothing you can multiply by 2x squared to give you x, so all that is my remainder, so it's just y equals 1.5x. This one, use the parent graph f of x equals 1 over x to graph each equation, describe the transformations that have taken place, and identify the locations of the asymptotes. Well, if you think about the transformations to 1 over x, what has happened? It's moved left 1, down 2. My parent graph, 1 over x, has asymptotes here and here. So what do I do with it? I move it rats. It won't let me grab the whole thing. Dang. These are my old asymptotes. I'm going to do the new ones in purple. I'm going to go left 1. So left 1. I don't like the way this looks. Let me erase it and do it again. Maybe if I draw it with a dotted line, it'll let me move it. And okay, so I go left 1. Yeah, you're laughing at me as you're watching this video. Shoot. It's not going to let me do it. That makes me angry. Alright, so I go left 1, so I'm just going to redraw it. Left 1. And down 2, so it's going to move down 2 here. Okay, and the 3 is going to stretch it vertically, so it's just going to be kind of somewhere in here. It's not really. 1, 2, 3. As kind of a guide, I just count away 3. 1, 2, 3, because that's kind of stretches it that way. And that's it. And then this one, it goes right 3. 1, 2, 3. Draw my asymptote. Up 3 from the plus. Up 3. 1, 2, 3. It's negative, so instead of being here and here, it's going to be those two areas, and it's a 4, so 1, 2, 3, 4, and 1, 2, 3, 4. Okay, and last one, graph the following. First thing you want to do is you want to look for any asymptotes, holes, vertical, horizontal. I see that I can factor this into x plus 5 and x minus 2. The x minus 2 actually cancels out. We've talked about this before. What happens when something cancels out? It makes a hole. So there's a hole at x equals 2. So what you do is you graph y equals x plus 5 and you put a hole in it. This is a line. So I go up 5, 1, 2, 3, 4, 5. Up 1 over 1. Up 1 over 1 until I get to 2 and I draw a hole. Up 1 over 1. Up 1 over 1. And it looks like that. This one, same thing. This is x minus 4, x plus 3. X minus 4's cancel. I get a hole at x equals 4. So, move up 3. 1, 2, 3. I go up, it's y equals x plus 3. I didn't tell you that. You go up 1 over 1 because that's my slope. Up 1 over 1. Up 1 over 1 until I get to 4 and I put a hole. I got into it. It's okay. And that's it. Alright, so if you try your homework, see how you do.